Test. That doesn't seem right. Is it even plugged in? Oh, I see. Okay. Okay, for now. Just do this. What? What the hell is going on?
Wait, fuck it. Wait. I don't even understand why it's not. Can I even open this stuff? Wait, how about now it's here? Okay. So, alright. Whatever. Okay, alright. So, today, we're just doing some basic stuff, which is taking this PCB that I designed and had ordered and then reflow hot plated, and we are going to finish assembling this. So we're going to put some LEDs in here. We're going to open up KiCad, and then okay. All right, so this is the schematic for the board. And what we need to do right now is figure out what the hell this power jack is. Where's the power? Output, logic, DC, and coupling. Okay, so pin 3. So wait, actually we need to open up the PCB. Kind of want to just get this done, but let's just figure this out. So this is 3. This is a no connect. So we don't even care about this thing. And this is... I mean, realistically, that could have gone to ground as well. I could, like, hot patch that if I really wanted. But the idea is that I have this thing, and we're going to solder it on. And so pin 3 is that one. Okay. So pin 3... Okay, so what I want to do is let's just get the camera set up. Let's get started with the freaking day. Oh boy, you know, it's always a process. All right, let me get the camera. We're gonna try to do this relatively quickly. Yeah, we'll need this. We don't need this. We don't need this. I don't need this tape. By the way, I was reading about this thing that is so sick. Let me see if I can pull up my ChatGPT log because I was reading about this thing that's okay. So for context, I've been really wanting to do. I don't know. Maybe this one's dead. It's probably dried in there. I don't know. Whatever. I've been really wanting to do this thing where I can okay, basically you have a petri dish, and on the petri dish is some cells, and those cells are producing proteins that fluoresce. And what that means is that given some excitation light, some light of a given frequency, that light interacts with the protein in a special way and causes it to emit a light of a different frequency. And that's just like super interesting. And I think that's just the definition of fluorescence. But what I want to do, and we have this thing called a blue box. I don't know if it's called a blue box. I've been calling it a blue box. And it has literally no labels on it. So I have no idea how to find what the hell it is. It seems like it was just a DIY thing, but it's made out of like nice acrylic. It looks like whatever. The point is that the stack up is you have a light, you have what's called an excitation filter, because the light that you're producing may not be of the right frequency to excite the protein. In my case, GFP. And if you see my other streams, that's what's happening. And okay, so you have this light. It gets filtered to the specific frequency that excites the protein. And I think then you add a diffuser. That diffuser makes it just like diffuse so that it'll hit the entire agar plate. Then that'll hit the cells or the colonies, and that'll excite whatever. And then you have an emission filter. So the emitted light, you want to select just for that. And then finally, you have a little plate that you can look through. And what I want to do is I want to make my own so I can do a time lapse, because I can't take that thing home and I don't want to leave my camera there just stealing the blue box. Now, here's the interesting part though. They have these things called liquid crystal tunable filter. And I don't know exactly how this works, and I've always wanted to do something with I mean, look at that. That's so cool. I've always wanted to do an optics project. But anyways, the bomb cost, let's see if I can get a chat. It generated a stack up for me. So it's not the best image. Can we just... what the fuck is that about? Bro, what? You gotta be kidding me. Alright, you can see it from here. It's fine. I really can't download it. Alright, so you have the camera at the top. Then you have just a normal imaging lens. Then you have an emission filter. And this is a static emission filter. There's an optional LCTF filter here. Anyways, what an LCTF is it's a way to programmatically make it... It's a programmatic optical filter. It's a way to basically select for a wavelength of light, but like dynamically, which is so sick. I mean, you know, that's really cool. And basically then you have your petri dish. Then you have something to hold it. Okay, now here you have a diffuser. You have a polarizer. And I don't understand exactly how these liquid crystal variable whatever are. Oh, they're called like variable retarder. So apparently you need 2 of them. You can even have 3. But the thing is, each one of those, that's the expensive bit. Most of this other stuff, I mean, a lot of even the polarizers are on the order of hundreds of dollars, and these lenses are kind of expensive. But basically, you have this white light. It gets collimated, which I guess collim. It turns it into parallel lines, I think. Then it selects for a whatever. Anyways, the cool thing about this would be then I could take agar plates that have a bunch of different... I mean, the ideal thing is that if this LCTF was on the top side too, basically it would be like the perfect thing to image plates with fluorescent proteins on. I think what I'm gonna do instead, maybe we'll see if I even get to this, is um we're going to just have a PCB with a bunch of different LEDs at that are the specific frequencies of um the most common fluorescent proteins, or the proteins that I want. I'm going to find a bunch of proteins that are fluorescent that I like, and then I'm going to put them on a PCB, and then the idea is that I'll write some software to sync up. I don't even know how I'm going to do this. I haven't even thought this through, but I really want to do time lapses of this. Okay, so it looks like, okay, so let's get this show on the road though. Enough talking about fun other projects. Time to finish a project that I actually need to work on. It's it's All right. So got the tripod. I think we gotta go full. So let's do. That's good. Oh shoot. Oh, I don't have power. Okay. I don't think that this thing works with the mic. Fuck it, let's just put these here for right now. Okay. So, all right. So let's just do something. Let's see. Okay. Oh no, I messed with this thing. Let me see. I forget. I forget how to do this. Yes, I messed with this shit. I don't even remember what I did. There we go. It's just info. Okay. All right. So we're pretty much ready. That we need this. We do need a soldering iron though. Okay. Yeah, I think I'm gonna open the window. I need some natural light in here. Okay, now we can move the mic over.
Bro. Wait, but if I switch scenes, does it...
There we go. Okay. All right. Cool. Okay, so here is the idea. First, we want to strip this wire. Oh, I know where the good ones are. Whatever, it doesn't matter. Okay. All right, so the plan is to strip this wire, figure out the continuity. Probably 22 gauge. That worked well. Okay, so now we have some wire. Now the idea is that we are going to take one of these terminal blocks, solder this together. So let's turn on the soldering iron and get some solder, and then you know what I think I'm gonna do? So we need to figure this out. So where's a Sharpie? Okay, so in the schematic we have the barrel, and then we have the outside part. And then in here we have like this one with a dashed line, and then we have something that's blank, and we need to figure out what the continuity is. So first off, let's just look at the schematic for. Okay, so this goes to pin 1, and it's 5 volts. It's expecting 5 volts. Then this is pin 2, ground. Now what we need to know is basically, I'm going to turn on our voltmeter. We're going to put red to pin 1, which I need to look at the PCB. Is the back. Let's see, can I get this around there? Not really. Okay, this is going to fall off. This is going to be jank. All right, and then we need to connect. And let's do sound. Why is it so jank? Okay, so I don't know if you heard that, but then where did I put that Sharpie? So there, so this connects to this. So this is the plus, and then the this one is the minus, and this goes to there. Okay, so now that we figured that out, yeah, what we'll do is let's think about it. I mean, I kind of don't even want it this long. I think I want it like this long. The point here, the reason why we're doing this is because I have this 5 volt thing that I use all the time for breadboards, but it would be nice if I could just pop in a barrel onto it. So I could just go like, let's see. Oh, they're already screwed down. So we need to get a screwdriver. All right, but that's the idea. So we'll do that. Okay. Okay, so now we need to solder this together. And it doesn't actually matter which way, but I do want it to be like this. Okay, let's get a hand. Okay. This might interfere a little bit. Or let me try to wrap it around. Let's see about that. Can I? This is such a mess. Okay. Okay, I don't even know if that's in shot. Let me check. Yeah, it kind of is. Okay, solder. No, we have so much heat shrink tubing. Okay, so we want like a tiny bit of this stuff. This too thin, this too thick. Even this might be too, this might be kind of the right size here. So we want this. I never really used heat shrink tubing on my own before, I think, but I feel like now is an appropriate. So we're gonna have this go on here like this, but of course we want to cut it. So let's cut it. That's probably good. So then this is gonna go on here like that. We're gonna oh wait, this is the wrong one. This. Let's just pull this apart. Okay. So this goes on here, and then let's get the black one. This stuff seems kind of thick. I don't really want to use. I want to use this stuff. But I have so much other stuff to do that this is almost like, why am I doing this? Oh wait, and I put it on the wrong one. So this is plus. And this is minus. Okay. All right. All right, that seems good. Turn on our fan. Fucked it. Fucked it all up. All right. All right, it's fine. All right. I honestly don't know if this is gonna go over that contact well. Oh, and this one I totally fucked up because I touched it. See, can I rip it off? Alright, that one is just gonna need some electrical tape, I think. Okay, let me just get some electrical tape. And then let me get a lighter. I thought I had a lighter. I don't know. I'm not pulling up the heat control of that. Okay, so now the idea is, I think you just go like this. So, let's do that. Make sure it's really around there. Okay. And then I think you just light it. Wait, I think I burned it. But it should be good. Alright, so that one was messed up. Let's just get some electrical tape and fix it. Okay. Okay, that's good enough. So the idea is that pin 1 is at the back. So this is the 5 volts. So the red should be connected. So if I go in here like, oh, let me get my screwdriver. Do that. Stick this in there. Do I want to do that? Here, let's just do it like this. So 5 volts here. We have a continuity mode. Fuck. Alright, so it beeped. So that's good. So now, pin 2 is this. So now we want to check that we hook this up like that and pin 2. Alright. I don't know if you hear, but we got a beep. So there we go. So that's this kind of jank setup. So now we have a barrel jack. This barrel jack is going to go onto this PCB right now. And we're going to solder that just like that. Let me turn this on. Okay, so now that we have this barrel jack in here, what we want to do, well, we want to solder the rest of this. We're basically ready to do that. So let's just put away the heat shrink tubing. Okay. So the next step of this whole thing is to get the other parts. So we need this thing, which is this part, which is what is that? I don't remember. We need to get the HTML bomb. So oh, that's a trimmer potentiometer. Okay, that's a trimmer potentiometer. So let's get that part out of our big bag of parts. Here we go. Okay. Oh, and it snaps in. That's so sweet. And then we can tune the clock with a screwdriver. So let's just pop it in here. Pop it in. Okay, it's a little janky, but it'll do. I mean, the connection's fine. But yeah, I don't love how it turned out. Let me see if I can. It's just not very level. All right. What is this last part? Oh, we need LEDs. We need to get some LEDs. Okay, so this last part is the. Key. Well, let me see on the 3D. What? This doesn't have any of the 3D parts on it? It's not right. Okay, let me just look on my GitHub. Oh, that's the button. Okay. It's the button. Okay, so I actually the way I like to do this generally so that it lies flat is first get it to lie flat. Let's see, am I in shot? I have no idea. I need a freaking autofocus thing, man. Okay. Okay, see, now that I have one, we're good. I can turn it upside down. All right. Okay. We have the button. We have the knob. I don't really love this knob, actually. This knob kind of stinks. It's okay. It's fine. It's fine. And then we have this thing. Now we just need to figure out some LEDs. I have these small ones that seem like they're the right size. But I want to try with the big ones. No, I mean, that seems perfect. Let me try to get my normal sized ones. Just see. It's, okay, so these are more standard. These are more standard. Actually, these work perfectly. I want to do these. These are way better. So now all I need to remember is what side is plus, what side is minus. Okay, give me a sec. All right, if it doesn't work, it doesn't work. But I think we're good. Okay. All right, so we get the I think out 4 is the Okay, we're almost ready to test this thing. I'm kind of nervous, man. That's one of these moment of truth things. It's like, is it gonna work? Cool beans. All right, so let's just get some snippies. Get some snippies. All right, I think we're ready to freaking plug this thing in and try it. So this is the signal out, so we don't actually need this. Um, so here's what we're gonna do. We're gonna take this thing that we made. We're gonna unscrew this. Red to red, black to black. Okay. Okay, so now we have this thing, and we can plug this into here. Seems good. I mean, I guess let's just freaking plug it in. Please work. Please work. It works. That's so sick. Okay, wait. Wait. Something's wrong, though. Oh, wait, no. Nothing's wrong. When this is like this. Ha! That's so sick. It works perfectly. Alright. Let's do a video. Okay, let's do a video. This is so sick. It worked perfectly. Everything just worked. Maybe the only other thing we really would need to test is get this thing on the oscilloscope, and then it would also be good to try out the halt, because this thing can halt the program. But I can't believe it worked. I mean, I know that I just copied a design, but wow, my first PCB. So sick. Okay, so where did I put all those PCBs? Okay, so okay, so this works. So now we're gonna do a video where we demonstrate that these do the same thing. And so to do that, I'm going to unplug our power. Okay, and what we're gonna do is we are going to unscrew this. Fold them back over. Okay. Now we have this. Let's just double check that this one still works by plugging this in. Okay. So we have our clock. Now we have our switch. And we have our button. Okay, so now all we have to do is get some wire. Where are my good strippers, man? I need my good strippers. Okay, no matter. I don't care. I don't even care. Alright, so let's just get some wire to the wire. Let's cut it. Let's get these to be the same length. Cool. That's a little bit long. Okay, so now we can put black and black. So wait, let's unplug. All right, are we ready to have them both working at the same time, man? All right, let's do the video. These two circuits do the exact same thing. They're a clock with three 555 timers. It basically gives me two modes. I can have a clock at a normal frequency, or I can change this. And see, this is the real output right here. This is the important one to pay attention to. Same here. You want this to be the important one. So if I flip this switch, that's going to stop oscillating. Okay? We still have our clock, but now if I step this by pressing this button, you can see here we can step our computer a single step. So this is a PCB I designed, and this is the breadboard version of this. It's the design by Ben Eater, and I just sort of made it a PCB. And I used reflow, hot plate, reflow to get all the SMT parts on here, and then I just hand soldered the rest of the through hole parts, and it worked on the first try, which I'm kind of shocked by. One thing is that this is the output signal. I could look at an oscilloscope for that. And then here, I have an optional halt signal, and the purpose of that is that if you have a computer that is running a program, you may want to just stop the execution and one of the entire machine. And one way to do that is to have a signal that just turns off the clock, because then nothing will be sent to the instruction decoder, and any of that stuff will everything, since it's locked to the clock, will stop. All right, let's posting time, and then I can get out of here. I can't believe this thing worked, man. It's it's I'm kind of surprised it worked, to be honest. Okay, so there's a number of other things to do now. The main thing to do. Circuits do the exact same. All right. I'm done with this. So I think what we're gonna do is I might research drawing tablets because I really need a drawing tablet because I like doing these animation things. They're really fun. Um, and then we need to figure out, really plan out and buy the reagents for this Gibson assembly, this hi-fi style Gibson assembly thing or whatever it's called. Um, and that's way more nerve wracking than ordering a PCB because that's like $500 worth of reagents because you got to buy the hi-fi kit, and then I need to buy minus 80 storage. Um, oh wait, here we're ready to post. Okay, so it's time to move on. All right, I think I'm gonna end this stream. Figure out uh this drawing tablet thing, and then we're gonna get started on processing or making basically a video on the Bradford protocol, which is a way to just quantify a protein concentration in a sample. And we're gonna do a little animation for that, I think. And the point of that is just to get a blog post for the Real Vegan Cheese thing up and running. But all right, let's cap this stream. Let's put a cap on it. All right, that was good.